All right. Hello, everyone, and welcome to Happy Hour Virtual Planetarium, brought to you by Pacific Science Center. My name is Katie, and I am a lead educator and planetarian here at PacSci. Tonight's program is presented by our hometown airline, Alaska Airlines. Alaska Airlines is a longtime supporter of PacSci and has been instrumental in our efforts to ensure curiosity never closes. They've shared with us this brief video. Programming like this is also made possible by donors like you. Science and an informed public are humanity's best hopes in addressing COVID-19, climate change, and other threats. Please consider making a contribution today and ensure that curiosity never closes. I'd like to welcome all of our PacSci members joining us today. If you're not already a member and you're interested in more events like this one, please check out our Fusion membership program designed specifically for adults. Perks include laser show and IMAX documentary passes, along with passes to some of our 21+ events. For more information, check out our website at pacsci.org/membership. Tonight, we will be talking about constellations and planets and the mythology behind them. In case you are unfamiliar with Greek mythology, it is full of 21+ themes and stories, so know that tonight may not be suitable for younger children. We will be focusing on Greek mythology because in the Northern Hemisphere, they are the most recognizable constellations, like the constellation Orion. In 1928, a governing body of 82 countries came together to vote on which constellations were most recognizable, and that is what we have followed since. But the coolest part about constellations is that many people across many different times and many different cultures have looked up into the nighttime sky and seen their own pictures and told their own stories. So I highly recommend searching through our YouTube page to watch some of our other virtual planetarium shows to see and learn more about different cultures and their interpretations of the nighttime sky. For most of human history, the night sky has been a place of wonder and learning. It was a place where many people have found pictures, have told stories, marked the passage of time, and helped to explain our relationship in the universe. So grab a drink, snuggle into your couch, and get ready to explore the sky tonight. At any point during our show, if you have a question or want to share a comment, feel free to in the comment section on YouTube. Tonight, I am joined by some amazing guest speakers who are going to join me now, and I will let them introduce themselves.
Hi, everybody. I'm a science communication fellow with Pacific Science Center, and I'm a graduate student with University of Washington working on my PhD. I study the moons of Jupiter and Saturn, especially Europa. And as you can see, I have a Europa Clipper shirt on. It's for a mission that's going there. And I know next to nothing about the mythology. So I'm actually quite looking forward to some of the things that we're about to hear.
Hi, I'm Sarah. I work at the Pacific Science Center as a digital specialist, but I also have a master's in folklore and a mother who's a classicist. So I grew up with a lot of Greek and Roman mythology, and I'm excited to share that with you tonight.
And hi, everyone. My name is Max. Along with Katie, I am also a lead educator and planetarian at Pacific Science Center. And today I will be the one controlling the planetarium program we will be using. So as I start to share my screen, Katie, what will we be looking at first?
So we are going to focus on things that we can see in the nighttime sky tonight from Seattle if we did not have any light pollution. Sadly, in the city, we never turn our lights off, so it's hard to see some of those stars. So in a planetarium setting, you kind of get to turn those lights down and see what's happening. So currently, we are looking at somewhere in Seattle, not sure where, but I think it's kind of cool looking, very lots of grass. We can see in the sky the sun being the closest star to planet Earth. It's what provides our sunlight. It is so close to Earth that during the day, that is the only light source we have in the sky. Stars are always out. They're just not visible because they're being drowned out by that light. So if we advance time and make the sun start to go away, Max will help us out with this. There we go. It can get a little bit darker and a little bit darker. And like I said before, many people have done the exact same thing that we are going to do tonight. They are going to look at the stars just like we are. There they are. They are going to find pictures. They're going to tell stories. And that is what we are here to do. Now, if you wanted to go stargazing in Seattle or really anywhere in the world, there are a couple things you want to know first. You want to know where you're looking. You want to know when you're looking. And you want to know what to look for. So here in the Northern Hemisphere, it's almost a little bit easy to know where you're going if you know what to look for. So in order to find north and in order to find your directions, there is a constellation, one of those dot-to-dot pictures in the stars that you want to look for. This is a bright constellation. Oh, it seems we have lost our planetarium system. Let's do this. I can pull that up. Well, while we're restarting our planetarium systems, because as we all know, sometimes technology doesn't want to work. So let's try this. There we go. It's back. All right, so if we want to speed up time once again here, let's see, there we go, date and time. And zoom back into night. There we are. So, like I said, we want to know where to look. So if we head towards the north, and we zoom out just a little bit to see what's going on up here. There we go. Like I said, those dot-to-dot pictures, there's one in particular. We want to look for the Big Dipper, also called Ursa Major. So the Big Dipper is composed of 7 stars, 3 in the handle and 4 in the cup. They are very bright stars and they help us find our way in the nighttime sky. So we want to look for 1, 2, 3, and 1, 2, 3, 4, our Big Dipper. So if we want to look at it, this, like I said, is a constellation that has more than one name. It's called Ursa Major for Big Bear. So Sarah and Moosh, I don't know if you can look at that and see a big bear or not. What are your thoughts on that dot-to-dot picture?
I have to kind of stretch my imagination a little. I've never really thought much of the descriptions from the Greeks. I've never seen them.
I mean, I guess I can kind of see a face. It looks like he has like a snout, a profile of a snout, and then like an ear. But again, that is also stretching it a little bit. But
all right, well, let's find out. It's a bear. Like you said, you kind of have to stretch it a little bit. Now, there's kind of a weird thing about this bear besides not necessarily looking like a bear. What does this look like to both of you?
A wolf?
Do you mean the diagram or the star chart?
The star chart.
It kind of looks like a person to me.
A person. Yeah, I think one of the favorite things that I ever got is it looks like a pirate with a peg leg that's missing its head. A 3-year-old once told me that in the planetarium, and I cannot unsee it.
3-year-olds are pretty good at coming up with stuff like that.
They are. So with this constellation, like I said, it's going to help us find where we want to go next. So if I take this down for just a second. So the Big Dipper, that bear in the sky with its long tail, helps us find the North Star. The North Star is very important in the Northern Hemisphere because it tells us the direction north. That's why we call it the North Star. As Earth spins around from day to night and from season to season, the stars move across our sky, though it's us on Earth that's moving, not the stars, all except for one, that North Star. It stays in relatively the same place because it is above the North Pole. So it helps us find our way, why we call it the North Star. And it's a part of a very similar constellation. It's a part of the constellation, the Little Dipper. Now, the Little Dipper is also comprised of the same number of stars. And if we want to pull up all of our constellations for just 1 second, we can give it away here. So in order to do that, I have to select this box. We'll look at all of them for just a second. There we go. Now, Sarah and Moosh, I don't know if you see a constellation that looks similar to the Big Dipper or not.
Yeah, smack dab in the middle of the screen right now.
Smack dab in the middle, right above north. Yeah, so this is the Little Dipper, also known as the Little Bear, because it has approximately the same shape, still that very long tail there. So the Little Dipper, like I said, is comprised of the same number of stars, but they're much more dim. So if we take this away for just a second, there are 2 bright stars here. One of them, this one right here, is that North Star. Our Big Dipper points us in the right direction. The 2 stars on the end point you towards the North Star. So if you ever get lost and you need the stars to find your way, it's very, very helpful. But once you know north, you now know the rest of your directions, and you can start to look at some other constellations in the nighttime sky. Now, Sarah, I know that you have a favorite constellation that you like talking about. Would you want to share one of your favorite constellations with us?
Sure. One of my favorite constellations is Cassiopeia. I'm going to get her up. So Cassiopeia was a queen, and she was incredibly vain. She boasted about her beauty and how gorgeous she was and how she was prettier than any of the gods and goddesses. Thus was her gorgeousness. The gods didn't really like that. They had a lot of human emotions, and jealousy was one of them. Anger was another. They were deeply offended, and so they told her to take it back, or they would make her sacrifice her daughter Andromeda. So Cassiopeia was like, but no, I really am that beautiful. I'm not going to take it back because it's the truth. I'm that gorgeous. And so Poseidon was like, all right, well, we're going to sacrifice Andromeda to the Kraken then, I guess, if that's the way you want to do it. And she was like, yes, I do. So they chained Andromeda to kind of a sea cliff. The Kraken was coming. She was eventually saved by Perseus, who's one of the few Greek heroes that has a kind of a happy ending. Andromeda went off and were happy. Andromeda was a lot more humble than her mother. And Cassiopeia was thrown into the night sky, and as a punishment, she was thrown there upside down to indicate that the gods were displeased with her, and yeah, she would live forever in infamy in the night sky as a constellation. I know.
Yeah, it's good. So this is a story that we like to tell in the planetarium as well, because it takes up a good portion of the nighttime sky. So you're talking about Cassiopeia, which is this constellation here. Cassiopeia, the constellation, is joined by her husband, Cepheus, also right next to her. Andromeda, their daughter, down here towards the northeast, saved, like you said, by Perseus, also in the nighttime sky, and his trusty steed, Pegasus. Now, Sarah, there's something that we have talked about before. I thought that Pegasus is something from the story of Hercules. That does not seem to be true here.
It is not true.
Before we move on, can I say one cool thing about Andromeda?
Please do.
So Andromeda is not just the name of a mythological figure. And one really neat thing about Cassiopeia is in the Cassiopeia constellation, one of those bright spots is Andromeda, which is the nearest galaxy to ours. So if you look really close with a very faint telescope and collect a lot of light over a long time, you can make out the shape of that spiral galaxy that looks very similar to the galaxy that we're in. So the many billions of stars that are in our galaxy are mirrored in that other galaxy.
Yeah, Moosh has a really good point. So looking into our nighttime sky, if we take our constellations away for just a second here, now everything that we see with just our eyes is within the Milky Way galaxy, within the galaxy that we reside, except for that one thing, the Andromeda galaxy. So the Andromeda galaxy is kind of hard to see on here, so I'm going to stop screen sharing with us for just 1 second so that I can pull up an image of this thing, because the Andromeda galaxy honestly is one of the coolest things in my opinion. Like I said, it's one of the only things that we can see. It is the only thing that we can see in our nighttime sky that does not fall within our galaxy. Now this is the Andromeda galaxy here. So Moosh, do you want to tell us a little bit more? Do you know anything else about the galaxy?
I will first admit that I'm not an astronomer. I don't study other stars. I have a background in physics, and I know more about habitable worlds and things going on within our galaxy. But our galaxy has a shape that's similar to Andromeda. So Andromeda is a good blueprint for what spiral galaxies look like. And so there's a lot of comparisons that we can make from looking out at the stars from within our galaxy to get a map of what's around us, and then compare it to this other galaxy and say, okay, our shape must be something similar. That's how we know that our galaxy has a spiral shape without being outside of it and looking at it.
Nice. Now, we get a lot of questions at Pacific Science Center about this galaxy because it is the closest big spiral galaxy to us, and there's all this talk, Moosh, about how it's going to collide with our own one day. Have any insights on that?
Yeah, a little bit. So when the galaxy next to us collides with ours, it's not going to be like an explosion. Things aren't going to be hitting by and large. There's so incredibly much space between all the stars that most of them will just pass by each other, and they might fling each other on different courses. But around our solar system, we're so tightly bound to our star that we'll pretty much stick together. It's extremely, extremely unlikely that an encounter with another star would tear us away from our star. And that's also billions of years in the future. So that's definitely not going to happen in anybody living now's lifetime, and not for probably beyond the lifetime of our star even.
So not something that we need to be worried about. Good to know.
No,
but
we
it
have
sounds
much more
like
important issues for the near term.
I agree. So it sounds like the only thing that really might change are potentially those constellations that we see, those stars that we see in our nighttime sky might rearrange, and we have different ones. Max, it looks like you're back with us. Welcome back.
I am back. Yep. Just the joy of working with the internet.
The internet is a great place sometimes.
Something I often like to point out about the Andromeda galaxy is, since it is on a collision course over the next several billion years, it's only going to get bigger and more noticeable in our sky.
Max, we do have a question about what kind of system we're using.
So this is a system called Stellarium. Stellarium, I currently am using the downloaded version. It is something very easy to look up and use the web version as well. The downloaded version, you do get a little bit more detail and a little bit of extra add-ons or extra things to look at, such as looking at different galaxies or nebulas. whereas I like to use the web version for just kind of a simple what might be in the sky tonight.
Great, thank you. So looking back at our nighttime sky here, the thing that might change when our galaxy collides with the Andromeda galaxy in many, 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 many years from now that none of us have to worry about. Good to know. So looking up, there aren't just stars and there aren't just those constellations that we can see. There are lots of other things, some of which we can head back to Moosh in just a second for. They are very bright in our nighttime sky, and they tend to look like stars. And I think one of my favorite facts about both of these planets, as we can see Saturn and Jupiter coming into view here, as well as Venus, they tend to be very low to the horizon and they tend to be very bright. And they most often get reported as UFOs. So if you ever report a UFO, just make sure that it's not one of our planets. Fun fact. Now, Moosh said he studies Jupiter and its moons. So Max, if you want to take us into Jupiter, I think it's time to take a better look there. There we go. Now, Jupiter is the largest planet in our solar system. It is a gas giant made of lots of gases here. Now, what we get to see too in this program are 4 other things that are very, very close to it. Now, just like Earth, Jupiter does have moons. It has more than one moon, unlike us. Currently, it has 79 moons that are recognized. I always like to think that there are more out there. We just haven't found them yet because it's such a large planet. Maybe Moosh has different opinions on that. But also, I am very biased of these moons as well because I am a marine biologist by training, and one of those moons might have an ocean on it. Moosh, can you tell us more?
Absolutely. So we are beyond a shadow of a doubt certain that Europa has an ocean, and Ganymede extremely likely also has an ocean. Callisto may or may not. There's a lot of active debate on that, but the reason why the Europa Clipper mission is heading to this system is to study Europa, because it's so exciting of a topic for study, because it has that subsurface ocean and a lot of conditions that we think might be important for developing life. And what we can see on our screen here, all these moons are labeled with J and then a Roman numeral. And that's because they're all sometimes referred to by astronomers as Jupiter 2 and Jupiter 3 and so on, and Jupiter 1 in the order of the moons they are out from Jupiter based on their discovery. So these are the 5 biggest moons of Jupiter. And though that high number of like 79, I think, moons, Katie said, a lot of those are smaller objects. So it's kind of loose, the definition of what is a moon, basically just something orbiting the parent planet. But these are all the big ones that are important for study because they represent solid surfaces that life could potentially be living underneath, likely. And Ganymede is big enough that if it were not orbiting Jupiter, it would likely be a planet in its own right. It's even bigger than Mercury. It's mostly made of ice, though.
Yeah,
So
go ahead, Matt.
Ganymede is bigger than Mercury. How similar to like Earth or even our own moon is Europa?
That's a really good question, and I actually do know the answer to that one. Europa is very close to the size of our moon. It's within a few percent the same radius. So the size of the object is very, very close to the same size as our own moon.
Sarah, I am always interested in the names of these moons. Do you think there's some mythology going on here?
I was just actually thinking that it's so interesting that Europa has an ocean on it, because the myth of Europa includes an ocean as well. So Zeus came to Europa in the form of a white bull. Bulls were really important in the Minoan traditions. Bulls and cows were all over the place, affiliated with Minoan mythology. You get the Minotaur, for example. You can see a lot of ancient vases have like people jumping over cows and stuff. So they're prevalent. And then Europa is affiliated with the Taurus constellation as well, probably because Zeus came to her as a bull. Taurus is bull in Latin. But Egyptians, Greeks, and even Babylonians connected the Taurus constellation with the horned animal. Anyway, Zeus transformed into a bull because he wanted to seduce Europa and was like, bulls are sexy, right? Europa was the king of Phoenicia's daughter, so she was like important. And Zeus went over and stood in the middle of her cow field and was like, I am the kingliest and like most handsome and beautiful of all bulls. Please pay attention to me. And it worked, because I guess that was the thing. And Europa went over and decided to sit on this bull's back because that's what you do with wild, strange bulls. Please don't do that. I don't think it'll work out the same way for you. Anyway, the ploy worked. Europa sat on his back, and then Zeus, as the bull, just took off and waded into the ocean and swam across the sea to Crete. And Europa was like, oh, I can't swim, so I'm just going to stay here and not try and get back to my field in my kingdom. So he took her to Crete, and then he transformed back into Zeus and was like, hey, I'm actually Zeus. Prepare thy ovaries for me. And he brought her affection with tons of beautiful presents, and she was very awed by these. They seemed to have worked. They had 3 sons together, somehow without Hera's intervention. And the most famous of their sons was Minos. And he became the king of Crete. He built a palace on Knossos where bull games were held every year. So they kind of wrapped in the bull to the mythology and like the identity of Crete as well. And Zeus was super jazzed about this. He was like, oh, great, bulls, king, fantastic job, and promoted the bull to a constellation by placing it amongst the stars in the sky as well. So Taurus is different than, of course, Europa the moon, but it's interesting to have this kind of theme that connects disparate constellations, or I don't know if you call them space anomalies, moons, identified objects in space.
Yeah, one thing I have found as I learn more and more Greek mythology is sadly Disney has lied to me. Pegasus was not in the story of Hercules. The moons have their own kind of different things going on. Like Hera was not the nice person as she appears to be in Disney movies either. I know that in order to study these moons and this planet, since it's very far away from Earth, humans cannot go there safely. We have sent things out to study it though. Moosh, can you tell us a little bit more about what is studying these moons?
Yeah, sure. Right now we have a mission, we being NASA, and I think it has international collaboration as well, has a mission out there called Juno, and it's orbiting around Jupiter's poles. So if you look at where all of the big moons, so Io, Europa, Ganymede, and Callisto, those are the 4 biggest moons of Jupiter, they all orbit around Jupiter's equator. And that's because they probably formed out of the same material as Jupiter. And so they all spin the same way. And that's why like all the planets around the solar system orbit in kind of the same plane. They're very close to all in a line, or sort of very close to in a line there. And if they've formed out of the same material, then they're all going to orbit around the equator. So Juno orbits around the poles because it's studying Jupiter's magnetic field primarily, and Jupiter itself as a body, as another primary focus for study. Other missions like Europa Clipper that's going to be launched in probably the later part of this decade are going to study the moons. So that in order to do that, they need to orbit around the equator of Jupiter so that they can pass by the moons with greater frequency. Juno doesn't actually get close to any of the moons because of being in a polar orbit. So going near the poles when it comes close, and then going outside of the plane of the moons when it goes farther away. And there's another mission that studied the Jupiter system around the turn of the century. Sorry for my cat scratching over here. He's very rambunctious right now. There's another mission that was in the Jupiter system at the turn of the century called Galileo, and that's where most of the information that we know about the moons of Jupiter has come from, and that includes pretty much all of the good pictures of the moons. They've all come from that mission. And it's named after the person who discovered the moons of Jupiter with his rudimentary telescope, Galileo.
Very cool.
Now, Max, we just learned that the satellite that is out there studying Jupiter and its moon's name is Juno. I do believe you have a fun story for our 21 plus friends this evening about Juno and the moons of Jupiter.
Yeah, so from what I understand, Jupiter is the equivalent of Zeus. Juno is the equivalent of Hera, and that this is for the Romans. For NASA to name it Juno, it was intentional because all of those other moons, Europa, as Sarah said, or Io, Callisto, Ganymede, are, I always say, named after Zeus's lady friends. And so Juno is kind of traveling around Jupiter, trying to figure out some of his sneaky ways and checking up on some of those lady friends to make sure no funny business is happening.
He was very sneaky.
There's definitely some funny business going on in Jupiter. There's a lot that we don't know about how it operates and how it works.
So it was definitely very intentional on being sneaky, taking an eye and keeping a look on things, and also watching over Zeus's lady friends. Yeah, that's definitely a fun name. Someone had fun with that at NASA. But speaking of Hera, so we talked about how Disney lies, right? But this is the time of year where a very well-known story of Greek mythology starts to appear in our nighttime sky. So at the very beginning, I mentioned the constellation Orion because that is one of the well-known constellations. Now, Orion is what we call the winter hunter or the winter hero. It's a constellation that appears in the northern hemisphere in the nighttime sky in winter. So as we go from winter to spring, from spring to summer, a different hero appears in our nighttime sky, and that would be the hero of Hercules. Now, as Max brings up Hercules for us to look at, it is another constellation that has some bright stars in it that can appear different to different people. Along with Hercules, as we'll start to find in just a second here, there is also some of his trials that are in the sky. So Sarah, do you want to tell us a little bit about Hercules and his trials?
Sure. Actually, one of my favorite things about Hercules is the Roman name, right? Which the Greeks were kind of lazy, or the Romans were kind of lazy, and they just kind of copied all of the gods and heroes of the Greeks and renamed them to Roman names. So in Greek, Hercules is Heracles, which means the glory of Hera. Now, Hera hated Hercules. She loathed him because he was the product of one of Zeus' many, many affairs. And so she tried to kill him when he was a baby. That part is relatively accurate, by sending a serpent in. And Hercules was so strong as an infant that he killed the serpent. And because of that, his strength was kind of discovered and celebrated, and he became the glory of Hera, because Hera is the one who brought that out by sending that snake in to kill him. Hera continued to mess with Hercules throughout his life. I know this isn't quite the trials of Hercules, but she was a really important figure in the myth of Hercules because she was his arch nemesis, so to speak. Even though she was Zeus's wife, and in the Disney movie Hercules, they portray her as the loving mother. She was not his mother. She loathed him. And one of the things that she had him do was murder his first wife and children. She essentially sent him something that made him go momentarily insane. And so in a blood rage, she murdered his wife and children, and Hera was like, haha, I got you. And so Hercules, he remarried a couple times. He was all right. It was very sad, but continues to have that back and forth with Hera. And there you see even the constellation, he's fighting with the snakes, right? Well, that's the Hydra. But He's also kneeling in the constellation. So that's related to a couple of his trials. First, it's actually a really, really old constellation. It's it's documented as like pre-Greco writings. And it was, he was kneeling, and then Aeschylus, a Greek tragedian, who's probably one of the oldest Greek tragedians who wrote tragic plays, associated this constellation specifically with a tale describing Hercules as kneeling and exhausted after a battle with the Ligurians, which is one of his trials. And it's another interesting thing about the constellation is that usually most of the figures we have kind of looked at in the night sky were, as constellations, they weren't necessarily gods. They were mostly demigods or heroes or figures, but Hercules was granted immortality. And so him being up in the night sky was almost like a courtesy. Like, okay, we'll memorialize you this or immemorialize you this way, even though like technically you're not going to die because you're immortal like us now. So it's a little bit more about him.
Yeah,
Ursa
I
Major
found,
looks a lot. Oh, sorry. Ursa Major looks a lot more like a bear from this angle, and with all the
You're
stars
right.
drawn in there.
He does.
I always see a headless pirate waving.
yeah, so with Hercules, so we said one of his trials was the Hydra. So in his image, he's seen with that three-headed snake. So Disney did get that part in there, got the three-headed snake. For every head you cut off, more grow in its place. In the nighttime sky, we said some of his other trials were there. The Hydra is there. One of the better seen constellations, it's made up of more bright stars than the Hydra that we can start with, is a constellation called Leo. I think Leo, the constellation, is really cool because it was a constellation that across many different cultures has always been seen as the same thing. I think one of my favorite stories that I ever heard is that the Chinese astronomers saw it as a picture of something, I can't remember what, and for 10,000 years, or not 10,000 years, oh my goodness, for a very long time, they saw it as this animal and then eventually changed to see it as the rest of the world. So Leo is seen as a lion by many different cultures, and eventually by the Chinese changed it to also see a lion because they thought it looked better. So Leo the lion is one of those trials of Hercules. Sarah, do you know anything about Leo?
You're muted.
Sorry, I was on mute. The lion was actually his first trial, technically, or was a labor. They're the labors of Hercules is another term for them. And that was the Nemean lion that he had to go slay. And it was a vicious monster. This was not your normal lion. This lion was huge and angry and vicious, and it lived in Nemea and could not be killed with mortals' weapons because it had golden fur that weapons could glance off it. He couldn't be killed. His claws were also sharper than mortal swords and could cut through any of the armor that they were wearing, so he was like impossible to kill. And Hercules was so strong that he was essentially able to kind of kill the lion with his bare hands, and he didn't need weapons or armor to fight it.
That's pretty cool. Yeah, Leo, like I said, is one of those more well-known constellations. It does have some pretty bright stars in it. One of them labeled there is the star Regulus. So if you are a Harry Potter fan, some of the names came from the nighttime sky, constellation, stars, etc. Another one that is in the sky right now, so very close to Leo, very close to both of the bears, is another constellation, also a well-known name of Draco. Draco the dragon, the constellation. Sarah, I also believe this is another one of those trials of Hercules.
Yes. This one I actually don't know quite as much about. Let's see. If I remember correctly, he had to steal its cows. I
Oh, wait.
don't quite remember this one, so I'm gonna have to pass on Draco. Max, can you help me out?
I've heard mixed things on it. I've heard sometimes Draco is included, sometimes not. Something I always like to point out is, Sarah, as you kind of mentioned earlier, maybe that's why Hercules is kneeling. He's kneeling on Draco's head because he finished one of his impossible tasks.
That's a great interpretation of it. There are the labors of Hercules have variations in them as well. Like any oral tradition that's passed down, there's going to be a little bit of, telephone, right, happening. So there are different variations from different scholars, oral historians, like Homer. Homer was an oral historian. He sang actually things like the Odyssey and the Iliad. And when these myths transferred over or when the Romans kind of appropriated them, they also came up with their own variants on some of the similar things.
I always think it would be fun if we went back to that whole idea of singing our history, so that throughout the entire day, everyone just had to sing what they were doing. That would be a very interesting world to live in, I think.
A good way to remember it.
Yeah. Now, with these constellations, so between the story of Cassiopeia, between the story of Hercules, that's a huge portion of the nighttime sky, a lot of the constellations that we can see in the Northern Hemisphere this year. With those constellations and with Jupiter, there was one more bright thing that was over towards that planet that I think we should also visit. So we talked about Jupiter as being one of those places where NASA and the European Space Agency are trying to send voyages to study those moons better. Europa, for example, is so important because anywhere on Earth that we've had water, at some point in time, we've had the building blocks of life. So if you can find water in the solar system, that could be a place to start looking for the building blocks of life. Like Moosh said, Jupiter is not the only place, Europa is not the only place that has liquid water potentially, or as we now know, Europa definitely does. There's that other planet, Saturn. So if we want to head to Saturn, there's some other cool things that we can talk about with the ringed planet. I think one of the coolest things that I ever read from NASA is that they took a poll of their workers, and one of the commonalities that they had is they decided to study space or work for NASA because as a kid, they looked through a telescope and saw the rings of Saturn, and the rest of their life changed. Moosh, I don't know if you've ever looked through a telescope to see the rings, or if you want to tell us about Saturn. I think it's a pretty cool planet.
I have. I grew up in a remote area in the mountains where there wasn't a lot of light pollution. And so occasionally we would set up a telescope that my grandparents gave us, me and my siblings, in our driveway and look at the planets. And I did see Saturn's rings through a telescope when I was a teenager. So I would certainly say that that story applies to me. One very neat thing that I learned actually just today is that there's been some recent research about the age of Saturn's rings and how they relate to its moon Enceladus, which is another one of those moons that we know for certain it has liquid water because we've seen pictures, we've taken pictures of geysers streaming out of its south pole. Enceladus may be very young on a geologic timescale. It may be less than 1 billion years old, and practically everything else in the solar system is several billion years old. So it could be very young, and it could be related to how the rings of Saturn formed. They're probably a recent phenomenon.
So Moosh, do we have any idea on how the rings formed? I've heard so many different theories.
The one that I would buy into the most is that something orbiting Saturn got inside what's called the Roche limit, where the gravity of that body pulling itself together is not quite as strong as the planet pulling on one side. So it slowly siphons off material. And as it siphons off material, then that body will rotate in its heavy side toward the planet. And so it'll slowly just spin off all of its material.
I like that one. Now, I think the other thing that I get most often at the Science Center about the rings is that one day people would like to go ice skating on them. Now, I think that might be kind of tricky. Moosh, do you think we can go ice skating on the rings of Saturn?
No, they're not a solid object. It's conceivable that somebody could potentially, in the very, very, very distant future, go ice skating on Enceladus. But I think that it's, I mean, I don't just think, it would certainly be impossible to skate on the rings because they're not a solid object. There's lots of space between the dust particles. It's kind of similar to the stars in our galaxy and the stars in Andromeda. Like if the galaxies were to collide, there's so much space between them that the stars themselves wouldn't actually get that close to one another. And likewise, in the rings of Saturn, the grains are not close together. Like if you picture Star Wars, like going through an asteroid belt kind of situation, that's not what our asteroid belt looks like. And that's not what the dust grains look like around Saturn. It would be hard to see multiple dust grains in one view when you're up close.
So
that's crazy, because from this view and what I've seen, and Moosh, maybe what you've seen as well, it looks like a solid ring.
Yeah, the particles that are there are reflecting light from many, many different places. And when you're very far away, they can all be at different distances to one another from you. And they're all like, what you see is the bulk property of all the light that's coming from the sun being reflected from different places back toward where you're looking. That's why you can see it anywhere you look. If it were a flat object, then it would reflect the light like a mirror. And because of its three-dimensional structure and the spread of the particles and the roughness of the particles, you can see it from any angle. It's lit up at from any direction. So it's a kind of a neat thing that we can see such a solid looking object from a distance.
That's so cool. Now, to me, what you described of the rings of Saturn almost sounds more like an extreme parkour challenge than it does ice skating. So if we want to bring parkour back, I think Saturn's rings would be a good place for that. Yeah. Now, looking at these, so once again, we said that Enceladus is another one of those moons that has liquid. Now, there is another moon of Saturn that we do hear a lot about, Moosh. Can you tell us a little bit about Titan that we see there in the far off screen?
Titan is very interesting because it's so different from so much else in the solar system. It's the only moon with a mentionable atmosphere. And it actually has a thicker atmosphere at the surface of the body than Earth does. Its atmosphere is about 50% greater. So it has 1.5 bars, we would call it, where Earth has 1 bar at sea level. And Titan's atmosphere is made up mostly of nitrogen, but there's also quite a bit of methane in that atmosphere. And because of the light from the sun, that methane should get destroyed at the upper reaches of Titan's atmosphere over pretty short timescales, geologically speaking. So it's a big mystery right now in the scientific community of how Titan has as much methane as it has and where the heck it's coming from. We don't know a whole lot about the generation process of the methane on Titan. And one very interesting thing about the properties of that atmosphere is the atmosphere is dense enough and just warm enough close to the surface that methane condenses out and forms clouds and rain and lakes on the surface of Titan. There's a mission that NASA recently approved to go forward that's going to head to Titan called Dragonfly. And it's a quadcopter that's going to land on Titan and take off and fly around to different places. And it's pretty big. It's like the size of a car, almost a very small car, like a smart car. And the way that it can take off and fly without actually a whole lot of trouble is because the atmosphere is so thick compared to Earth, and the gravity of Titan is quite a bit smaller than Earth because it's not as dense and it's not as large. It's with its atmosphere, it's slightly bigger than Ganymede, and without its atmosphere, it's slightly smaller than Ganymede. So it's like right in there, like it would be a planet if it were by itself category. But Dragonfly is a really neat concept because it's hard to get things that can go to another planet and then move around. And this isn't going to a planet, but it's a very interesting topic for study because it looks like things that could have gone on in the early Earth, just much colder.
I do have to say that I've seen images and renderings of this mission and that kind of quadcopter, and it's really cool looking, and I want to know more about how you engineer something that almost looks like a giant drone to fly to a distant moon, land on it, and fly around. That seems pretty cool. Now, as we head back here, so Saturn, Jupiter, we have our stars. We've learned a lot about a lot of these things tonight. We do have some questions coming in, so I want to leave some time for that. So if you have questions, feel free now to send them in on the YouTube. We have some to start with. Moosh, I think this might be more for you, but how do Jupiter's moons not collide with each other?
That is a good question, because on a geologic timescale, it seems like the moons of like orbiting any object, especially if they're kind of close together, they should get close enough to interact. And actually the moons of Jupiter do interact with each other, and that's what keeps them from colliding. So they're in what's called an orbital resonance, where to use Io and Europa, for example, Io goes around Jupiter twice every time Europa goes around once. So they're constantly moving around, but Io goes around faster. And so for each 2 orbits Io makes, Europa makes exactly 1. And since they coincide at the same points in their orbits, they give each other little nudges that keep them being slightly eccentric. So they don't have perfectly circular orbits around Jupiter. And that slight eccentricity helps reduce their orbital energy. It helps dissipate energy to make it so that they stay in the same orbits and they don't deviate from that. They stay relative to each other about the same orbital distances. So that they can keep that resonance going. It's very stable. And so Io and Europa are in what's called a 2-to-1 resonance, because Io goes around twice every time Europa goes around once. And Europa and Ganymede are in a 2-to-1 resonance as well. So Europa goes around twice every time Ganymede goes around once. Callisto is not quite in that same pattern, but it's likely that within, by the time they all start to interact with Callisto, they will settle into a resonance, and then there will be a chain of resonances that keeps them all very stably orbiting around Jupiter.
Good to know. Sarah, I don't know if we're still looking at Jupiter. Is there a moon in particular you would be most interested to visit if humans could visit a moon?
Oh, well, Europa has an ocean. That sounds pretty cool to me. But I feel like Ganymede must be nice. Ganymede was a cupbearer. He was a son of the king of Troy and the most like beautiful man in the world. And so Zeus just kind of plucked him up into Olympus, Mount Olympus, and was like, "You are now my cupbearer, beautiful man."
That's one way to do it.
Sarah, corrects me if I'm wrong, but that is that the same story of Aquarius?
He is associated with Aquarius, yes.
Okay.
Max, is Aquarius a constellation we can see in the nighttime sky?
Let's go back to find out. I actually don't know. So I want to say it is.
As you look, I always like to think, so Aquarius is one of those constellations that we associate with the zodiac signs. So you have Aquarius, Sagittarius, Taurus was mentioned. I think one of the coolest things about these constellations, they are signs that we associate with when you're born. They fall on the same path along the sky as the path of the sun. So long before we had lights or anything like that, the sun was very important to humanity. When the sun was up, you could see what you were doing. You could see big scary predators coming for you. The sun was very important, so we tracked the path of it. One thing that Max has pulled up for us is this orange line. This is that path that the sun takes. It's called the ecliptic line, in case you want to look it up later. Now, all of those signs fall along it. So we thought long ago that because they fell along the path of the sun, they must be important. So we wanted to look more into them. And one of the things that we found, as you can see with Aquarius, is that as we looked longer and asked more questions, things started to act differently. So we can see that Mars is very close to Aquarius right now. Mars being slightly brighter than most of the stars down there because it's not a star, it's a planet, it's much closer, has a different color, and potentially, depending on the time of year, moves differently. Moosh, can you tell us a little bit about how planets move in the sky?
Yeah, so I like that. I didn't know that the constellations that are related to the zodiac all lie on the ecliptic, which is actually important because so do the planets. Everything that's on the ecliptic line is in the plane of our solar system. So I mentioned earlier that all the planets lie very close to our star's equator as it spins, and that is the ecliptic plane. So Earth orbits in the ecliptic plane. That's how we define it, because of that line that the sun takes across the sky. So the way that the planets move is around the sun. So we know that because predicting that they move around the sun is the best way to match what we see in the sky for how they move. But they always stay very close to that ecliptic plane, and they move throughout their orbits along that line and throughout our orbit. So our relative positions tell us where in the sky the ecliptic plane goes. And so like some of the planets like Venus and Mercury that are interior to the Earth's orbit always stay close to the horizon, because you have to be kind of looking with an angle to the sun, an acute angle to the sun. Whereas the outer planets like Saturn and Jupiter, they can rise much higher in the sky because they can be on the opposite side of Earth from the sun.
Good to know. Yeah, we can see on this line right now that Jupiter and Saturn do fall along that line. It's a very important thing to look at, since we wanted to track what was most important, the sun. And then as we started to see those other things, we started to realize that planets were there. We could see things other than stars, and we could start to find kind of like modern day astronomy. What are the questions that we want to start asking? I like it. Now, we do have another question about Europa. Like I said, it's a very, very exciting place. So Moosh, what is the possibility of there being life on Europa? It's a frozen planet with a liquid core. What's that all about?
Well, the core itself isn't liquid. Europa, the structure of Europa is such that there's lots of solid objects, including rock, on the inside, and then there's a thin skin of ocean and ice toward the outside layers. And the way that is kept liquid underneath the insulating icy shell there is from that orbital resonance with all those other planets. Because Europa is not in a circular orbit, it moves closer and farther away from Jupiter. And that change means that Jupiter pulls different amounts at different points in Europa's orbit. And so it's a bit like kneading dough, and that generates some heat. That is really important for the possibility of life being in Europa's ocean, because life needs heat. It needs not just the liquid water, but also needs an energy source. And so there could be, from the generation of heat at the interface between rock and water, it could be a situation where there could be something like a hydrothermal vent, like we see in Earth's oceans, where we're creating all the ingredients that life needs. Like there are thriving ecosystems around hydrothermal vents. And so it's possible that life could get started around one of those in Europa. It's very much an open question of how life got started on Earth. And there are a lot of different theories for what life might need to get started, including some that suggest that you can't get life started in a dilute ocean, that you need to have some way of concentrating nutrients. But we really don't know. So I am optimistic that that it's possible for life to get started there. And I think we won't know until we look there whether or not Europa itself is actually habitable. But all indications seem to be that it has what life would need.
So we need to follow Moosh's research.
Yeah, definitely.
Yeah, fund me and fund everybody else studying these topics. It's important.
Now, if we head back to Earth, Max, for just a second, look at those stars. So we have a question about the Milky Way. So Moosh, does the visible part of the Milky Way fall along the ecliptic?
That's an interesting question. And the answer is actually no. And that's because the orbit of the planets around the sun is not aligned with the galaxy. It's actually pretty close to perpendicular. So if you look, this is a really great image right now. You can see the line of the ecliptic, that orange line, once this pain goes away. That orange line crosses the Milky Way at nearly a 90-degree angle. And so the plane of the Milky Way galaxy runs crossways to the ecliptic plane. And that's what tells us that the orbit of Earth and the planets is actually not in the plane of the galaxy. So if this is the plane of the galaxy, we're orbiting around the sun like this, as everything orbits around the center of the Milky Way.
Yeah, I think one of my favorite things to point out, I actually learned from Max. So same on that ecliptic line is a constellation Sagittarius. I am always just partial to this one because I am a Sagittarius. But Sagittarius, the constellation, has part of like a little pot. So as you zoom in, there we go, kind of the arms and bow and arrow of the centaur that is Sagittarius almost looks like a pot. And when you boil water in a pot, that steam rises out of it. So if you rise the steam, which would be the Milky Way, out of that pot and follow up just a little bit, you're looking straight on at the center of the galaxy.
The Greeks had a different idea for what the Milky Way was.
Oh, please tell us.
It contributes to part of the reason Hera hated Hercules, because, or Juno hated Hercules, if we're going to stick to Roman names. But the Milky Way, so Zeus had Hercules with a mortal woman named Alcmene, and he was so enamored and in love with like the baby boy that he let Hercules essentially drink Hera's breast milk. And that's one of the variant reasons why he had like so much strength and power, is because of that. But the Milky Way is like essentially the line between mortal Hercules and the immortal goddess Juno, and her breast milk floating along the galaxy.
I have never heard that, and now I feel like I will never look at it the same again.
Sorry.
Yeah, I'm going to inadvertently connect that to the Juno mission now.
I love it. All right, well, we are winding down on time here. I think we've had some really good questions. I've learned a lot. Have you all learned a lot?
I certainly have.
Definitely.
Lots of neat things about the mythology that I did not know before.
Yeah, we learned a lot about science. We learned a lot about mythology. That's the cool part, I think, about looking up into the nighttime sky and getting to see everything that's there. For a lot of human history, it hasn't just been the scientific discoveries. It's been a lot of that mythology, a lot of that story. So bringing kind of the two together is a really good way to look and learn about the nighttime sky. So I think we will conclude there tonight for our virtual planetarium show. Like I said, we've done exactly what many generations and cultures of humans have done before us. We've looked up into that sky, we've told stories, we've found pictures, we've observed planets. We've even learned that the Greeks had some really interesting stories that I will never unhear or see ever again. Thank you, Sarah. I would like to thank our speakers this evening, and thanks to all of you at home for joining us. We especially want to say thank you again to our presenting sponsor, Alaska Airlines. Enjoy the rest of your evening, everyone. And from all of us at Pacific Science Center, remember that curiosity never closes. Have a great night.